Hello, Bella. When you watch this.
Oh, shalom, Bella.
Shalom.
Shalom.
Did you have to get back from lunch now?
Aloha. My tea is still warm in your cup, Bella.
Oh, yes. The pulled pork mac and cheese. Very much better than you think.
A new lunch that you have yet to try.
If only you were here to try it.
I was high-key impressed.
It didn't sound good, or I thought it was separate, but
No, I thought it
thought
was just a really weird meal.
Yes.
Pulled pork and there's mac and cheese in that.
It's kind of like beef and noodles. Like,
Freezing.
Are you on the Wi-Fi or no?
I've tried both.
are you guys ready for the extreme?
Oh, no.
I don't think I'll ever be ready, but you can try.
Is that the last one we were doing today?
And then we're
Yeah.
done.
Nice.
All right.
Is this gonna take up like a whole page?
What's that?
Is this gonna take up like a whole page?
Just have at least half.
Good.
To set it up.
It's a
Alright.
To set it up. Just to set it up.
Excuse me? I have half a page.
All right.
I love that movie.
All right. Okay. If I find the derivative of a function, right?
Yeah.
It gives me a new. I just about said Brady Griffin.
Because,
I'm sorry, I'm just kind of happy because I got a snap.
If
Team Snapchat.
Griffin, they like you.
shh. I just said shh, Nate. I was like shh. Yeah.
Corona.
Aruga.
You're ugly.
All right.
It's working,
Wait.
Nate.
No.
Oh,
Shh.
my bad.
Here.
Listen.
You hear what?
Listen.
Will, what can you hear? Your phone. Wow.
Buffering.
Okay, we can go now.
All right.
My
The
nose isn't clean. My
The-
nose-
What does it stand for?
Extreme value here.
Oh yeah, I'm stupid.
what do we mean by extreme?
Extreme.
Exactly. Yes.
Wait, what?
Excellent.
What do you mean
So extreme just means the minima
The maximum.
and the maxima.
Yes, I love those.
Yes.
No.
Now
They're
there.
so easy.
Now let me show you something. This is a function.
Right out.
Whoa.
Okay.
That is a function?
Oh.
What's
Okay, gotcha.
what's the maximum value of that blue function?
Okay, I forget. Do you take the infinities or no?
No.
Okay.
No, just
So
what
your
you see.
maximum's on the far left, the first column. Oh wait, so you do take the infinities.
Oh, that's just the endpoints.
Okay, then yeah.
Maybe.
Yeah,
First
and then
column.
your maximum's
Right
way down there.
Okay. What if we didn't count the endpoints?
Okay, then your maximum
The
is
first
the
top,
first
the top
column.
key. First key. Right there.
And then your last one will be the lowest.
That right there.
Good. What's that?
That is a
What's that shit
oh,
called?
what is it called?
Minimum.
Intermediate maximum.
Wow.
No, it's a relative.
Relative maximum.
Yes.
What?
So you have relative maxima,
Yeah.
right? Relative maxima here, here, here.
Oh, and you missed one. There you go.
and then you have relative minima.
You missed the first one.
Right?
That was the best one.
Stop it.
No
All right. So sometimes you might say that there's local maxima. So in its local neighborhood, it's a maximum. Before you find another maximum, there's a local minimum. You know.
Yeah.
So you can think of them that way, and versus the global maxima or minima. So that's what we're talking about. We're talking about the extreme values. So like
How extreme is it?
some could be just like in the locality. They're kind of extreme relative to the other things in the neighborhood. Or they might be the maximal point on the whole interval. Now, if the interval is like inclusive and non-inclusive of the endpoints, has an effect on whether or not you check the endpoints or not.
Sure, so if it's like open circle.
Right. Then you wouldn't
Right.
check the endpoints. But if it was a closed circle,
Then you would.
then the maximum and minima could happen at the endpoints, and you'd want to check those out. So what about so besides for the endpoints, that's kind of like the last thing you got to check to make sure that the endpoints aren't bigger or smaller than,
When I
The-
circle, there's an endpoint.
yeah.
Well,
So like, well, like, let's say
what is
this,
the top one?
let's say this is like -10 to 15.
Yeah.
Okay.
So like if it was, if your interval
Nice.
was like that, then it's not inclusive to the endpoints. So you wouldn't have to check at -10
Oh,
or
right, because we
15.
use the brackets, right?
Yeah, because technically -10 and 15 aren't included.
Right.
But if it was the hard brackets, so like
Yes.
it's
I
inclusive,
forgot about those, but
that,
you brought it right back.
very good. Then you would check the endpoints.
What did you say about the circle?
Like if it's, when you do interval notation, if you're not inclusive, you have an empty circle. That
Yeah.
was ugly. Oops. Right?
Mhm.
So for that point of the interval, you'd have an open circle, and for the interval, you just fill in. What?
You draw that.
Oh, you mean like,
In interval notation.
right,
Oh, yes. Yeah. I drew the graph.
But if you filled in the dots, then you check the endpoints. Right?
Could have been much.
so you didn't mean an actual circle.
Oh,
You
yeah.
meant like
I thought you were saying the graph. The graph is a circle.
I'm.
No, 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 no.
Oh, okay.
You good?
Yes.
All right. Other than the endpoints, depending on if it's an open or closed interval, you're going to, the only points you have to consider are what are called the stationary points. These are the points with 0 slope for the tangent line. That would be one stationary point. That'd be another stationary point. They're called stationary points because, like, when you, what was that?
They're doing like present video things they made. And
That wasn't distracting at all. So, like, they're called stationary points. If you think about throwing a ball up into the air, right? At the top, the ball, when it reaches the top of its trajectory, the velocity goes to 0. So it's technically stationary at that point for a brief moment.
But then it's actually.
What's that?
Yeah.
But then it goes
Yeah,
up,
because
and then
the
it
velocity might be 0, but the acceleration isn't. So the velocity remains changing even in that moment.
You can,
So these are called stationary points because it's where it turns around. It was going down, then it's going up. So right there, we had a 0 velocity for a moment. So these are the stationary points. How do we find them? We already talked about how to find them with Rolle's theorem. You set the derivative equal to 0, and the solutions give you the point at which, or the multiple points at which, there are stationary points, the turnarounds. Does that make sense?
Yeah.
So you just take the derivative, that gives you the velocity at any given point. Find where that velocity hits 0, that gives you the turnaround, aka stationary points. And then you found your contenders for what are called relative extrema. So altogether, they're extrema. Some of the extrema are minima, some of the extrema are maxima. Are we good?
Yeah.
The way you take, the way you figure out if there are minima or maxima, you can always put it into your graphing calculator if you have the function and decide, look at it. Like, is this x value at a maximum or is it a minima? You can use your graph. But the way you would do that if you didn't have a graph and calculators weren't invented yet. So we did that that this thing, right? This will find you your stationary point. Whoops, I don't want to leave that there. I want to duplicate. Let's go.
Take your time.
we took it too far. Oh,
No, we didn't take that far enough.
Yeah, I kind of exaggerated how much room we did. That was kind of a joke. So this will give you,
Well, the road is really fun to do.
what? Come on. I definitely chose the typing tool.
Off topic, but why are those chrome things images blue?
Well,
Because colors.
It's not chrome, it's chromium.
it's definitely.
Oh, the chromium.
This is the tool.
Full Chrome is over there.
Yeah, Marvel.
Chromium is the actual base browser. Google just takes Chromium and shoves spyware into it, calls it Chrome, adds some colors to the logo, and then are just
So what's better, chromium or chrome?
Chromium is Chrome or Chrome is Chromium with spyware.
Right, so if you don't want to be hacked
You use
or
Chromium.
spied on,
Yeah.
Chromium.
That's why I have Chromium. No, actually, I just have so many accounts at different schools that
Right.
if I'm in St. Mary Sterling, all my accounts, I stay logged in on Chromium. Newman, I choose Blue. Newman, I've got Firefox Web Developer. SOC, I've got Vivaldi. For my personal stuff, I usually use Firefox regular. And
Wow, that's a lot.
I do
Yeah.
though.
some at home for Newman, I use the Brave browser.
What's brave?
It's a privacy browser.
Use the glasses.
It's got a lion.
Oh, yes.
I
Oh,
know.
It has like a built-in VPN, and
Heck yes.
Well,
Yeah.
is it worth it?
Opera, I guess, is like
Firefox.
it's got a lot of spyware too.
Ooh.
It's a Chinese company though.
Ooh.
oh,
Oh.
Yeah, yeah. I like how like
Wait, go down. Go down.
I use Opera game.
Wait, keep going. Tor.
Tour browser.
Tor. Yeah,
That's how you get to the dark web.
that's based on Firefox, but yeah, it's built on
That's
Firefox.
how you get to the dark web.
Focus.
I've never used that one.
Opera Mini.
Just never this.
Have you been to the dark web? Just never this.
Oh, this one's actually kind of cool. Maxthon,
Hold up.
or is it Avant browser? There's one that has the Firefox engine in it, or the Chrome engine, and you can choose different web engines to see how they render,
Cool.
all within the same browser.
How about Bing?
What?
Bing.
Thanks.
B-I-N-G.
Nobody uses Bing. That's not a browser.
Yes, it is, right?
It's a search engine.
Oh, right, because it's Google.
The new Microsoft Edge is based on Chromium.
Yeah.
Let's talk about Microsoft.
Wait, so is Microsoft Edge
They-
free of spyware?
Oh, no, they're very spyware.
Is it better than Chrome?
It's based on Chrome.
Internet Explorer.
I use various. I use Chrome and Edge because they were on my laptop.
Microsoft gave up on their framework for Edge, and now the core of it is Chromium. So it is like Chrome now.
Great.
Wow.
So chromium is good.
Yes,
So we should get chromium instead of chrome.
I would. That's what I do.
What if I like
Chromium
people
is
having my
like
What
information?
about like Tor? What about like onion?
Then,
what if
then,
I was going on the dark web and buying children?
Then
then,
you're gonna want maps on.
if you're using Chrome, then Google knows all about it.
Yeah, maybe.
Well, no, that's why I use
True,
Tor.
if
That's
you
why I
use
use
Chromium, then no one will know that he bought certificates.
Well, you have to be careful.
Or I just go to Wayfair.
Tor even
Wayfair,
Tor even
yes,
tells
sir.
you that Wayfair. Tor even tells you that that's a conspiracy that I
No,
heard.
it's probably true.
It's literally true.
Why do they name the tablet Sarah?
Yeah, I've heard
Why do
it.
they do
Yeah,
that?
it probably is true.
Right.
Yeah, and then also the list of them perfectly lines up
Right,
with the list of
with
missing children.
And
They're
yes,
selling children.
yeah, they probably are.
Wayfair, you got
Elvis
just what I need.
What if you accidentally buy something, you just get a cabinet that ships in, there's just
You're just-
child.
You're like, oh, $1 million cabinet? Why not?
Why not?
I remember we saw like a
Must
I
be
saw like
the
a video about it,
funniest
and
deal.
everyone was like, someone was just talking about it, and they were like, "Don't be shy, buy one." Like, show us.
And then somebody got arrested for trafficking or something, and when they in his mugshot, he was wearing a Wayfair shirt. He was like an employee or something.
Oh my god,
Oh,
it
Wayfair.
just gets deeper and deeper.
Yeah, confirmed.
This web that we leave.
Oh, and then
Hold on, let's.
it's like a mattress story. You know what I'm
Oh,
talking
Yes,
about?
yeah,
Is that what it's
yeah,
about?
I heard of that too.
It's money laundering. It's everywhere.
A cement plant too also was involved.
Who needs that many mattresses?
There's literally one on every block. Like that.
It's billions of dollars industry in this country and all around the world. So
Right, and
yeah,
it's mattresses.
it's happening everywhere.
Interested in one area.
All right,
Only cocaine line.
let's get on to these little squiggly lines and what you can do with them.
Tell me what else.
Show me what you got.
I love that guy.
What?
the head.
Show me what you got.
I like when the planet is like, we will not,
We will not
live
say
out our lives just for your amusement.
disqualified.
Yeah.
Are we talking
There's one
treasure
every
planet right now?
season. What's that?
I said it was talking treasure planet right now for
No.
no reason. All I heard was you say planet, and I was like, ah.
No,
Yes.
it's in a Rick and Morty.
I know the one.
Show me what you
It turns out
got.
life is just a game show for aliens. South Park already did that.
Disqualified. Just kill somebody.
Okay, are we ready to finish this?
I absolutely am.
Okay.
I was born ready.
I
Good.
think Will and I have been ready. So it's fine. Can't speak for the rest of you.
Get swifty.
All right, if you take the derivative of the derivative, aka the second derivative, I'll change this.
Wow.
We've done that before.
Yeah, we've taken the second
Nothing
derivative.
bad ever happened. Who was that?
That's a 1.
Second derivative is easy.
We do that
It's the
one.
first derivative to derive.
X1. That way it's different from the X0.
Oh no, X1.
And then
That way we don't get them confused.
Why is it X1?
I'm just making it so it's not a variable. So
why
like,
was X0 X0?
just so it's fine. I'll make them 1 and 1 and 2 and 2. How about that?
No,
Wait, no,
It,
I just don't understand what the not even is, honestly.
Because like if I say my function is x squared, that's terrible.
Oh, that's just how you
Well,
say
what
it.
is stationary?
Well, that's a variable and it can go anywhere, right?
Yeah.
But if if I'm looking for the specific x that makes x squared equal to 4, then sometimes I don't want to leave it like a variable.
Right.
So I'm solving for,
But it is 2, right?
yeah,
Okay.
or plus or minus 2,
2.
Plus or minus.
Yeah.
right?
Right. So,
So-
X naught is just like making a variable out of a variable.
Yeah, like a lot of times you'll see in like science and stuff when they take a expression or a function and they set it equal to something and they solve for the variable for the value that makes it specifically true. They will mark the x as though it's like not a variable. It's or they might put an a. They'll make a specific thing that doesn't look like a variable.
Okay, I understand it for now.
Good 50.
All right, I'm making these 2s. You can do 0 and 1. It doesn't matter.
Yeah, I can do it.
All right, so those were stationary points when you take the first derivative and set it equal to 0. If you take the derivative again and find where that equals 0, what's that? These make the inflection points. So on this curve, we talk about when things are concave down versus when they're concave up,
Yeah.
right? So there's an inflection point right about here. Notice like if there was rain falling on this thing, the water would go down the hill,
Yes.
right? But if there was rain coming here,
But it would go down.
it collects in the bucket, right?
Yeah.
Will it go up?
Absolutely not.
So here, about here would be an inflection point where your concavity is downward and then it becomes upward, right?
Woo.
What?
That's an inflection point, go back.
So it was going, the concavity was down, like the cave opens down. Now the cave opens up. And there's this point where it transitions. Those are called the inflection points. It's when the acceleration was down, the thing, it goes up but it slows. Then it goes down but speeds up. And now here's where the acceleration flips. It's now an upward acceleration, so it's trending up.
Because.
So this is the point where the acceleration goes from negative. So if we have negative, at the inflection point, the acceleration will go positive. That's the second derivative, not the first. So if you take one derivative, you find, and set it equal to 0, you find where the curve turns around. And if you take the second derivative and set that equal to 0, those points tell you where the curvature changes. So where it goes from downward to upward curvature, and then from upward to downward curvature, you've got little points around here and here.
So
And then,
those are the inflection points.
yeah,
Even though, like if it landed at the inflection point, it'd still be going down, right?
yes, yeah.
Okay.
But now instead of accelerating down, it's accelerating up.
Okay.
So instead of like arcing like this, it's like, yeah, that's right.
That sounds like I broke the floor.
What?
I was like,
Yes.
what is that? Okay.
Sometimes you need sound effects. All right, once you have the inflection points, so let's say I know that this is an inflection point at this value of x. Let's say it goes from cave down to cave up. And then maybe here, it's caving up and it's caved down. And then maybe here-ish. Is that okay? So the first derivative gives you the stationary points.
I guess.
So I know that these are places where it turns around. These could be maxima or minima. If I just solved the equation, I didn't have the graph, I wouldn't know if these were highs or lows. But I know that there would be extrema at those turnaround points, or stationary points. The way I know which one it is, I find the inflection points, right? So here, here, here. This is where the concavity changes. If the concavity is down, I know that the stationary point in that range
It's maximum.
is a maxima. So if these are negatives, if the second derivative in between those two inflection points gives me negative numbers, then I know the concavity is down and that this would be a maxima. And if I start plugging in values in between these two inflection points into the second derivative, and I start getting positive values, I don't want to keep doing that, so I'm just going to do.
So hold on. This
Ah,
is like neat and all, but we wouldn't really need it, right? This, it's like to determine the maximum and minimum, and like, you could just see that?
yeah, if you had the graph.
Okay.
But we're talking about in the olden days,
No,
remember?
we're not in the olden days, tricky.
Yeah, but it's still part of the curriculum. So you don't have to always
So
do
we're gonna
this.
learn it, but like,
Yes.
if it was on a test, we could just graph it.
Correct. Yeah.
Oh, nice. That's nice.
It's just a couple extra steps. It's not
Or rather
hard.
graph it and then figure it out.
It's basically just like this. You do it again, and then you check in between those points. If it's positive, you know that's a minima. If it's negative in that range, you know it's a maximum.
So that we all need to know for EBT.
Yeah, pretty much.
Oh, really?
Wow.
Yeah, you find the stationary
We
points.
got 5 minutes.
That didn't even take me a page.
No.
That took me.
Let me give you some background.
We're good?
We're good.
Yeah.
let me just summarize though.
I did write a lot.
You have the first derivative that gives you the slope. Find when that's 0, and that gives you the points where the function turns around. Those are going to be your max and mins. And then you just have to determine if they are max and mins. You can use the second derivative to do that. But you don't usually have to because you probably will have a graphing calculator.
Okay,
However, I will ask you where are the inflection points. So you will have to at least set it equal to 0 and find those zeros.
Okay, so
Wait,
the
so
first derivative gives you the slope,
Yes.
and the second derivative gives you the inflection points.
Yeah, this is kind of like the velocity, the rate of change. And this is kind of like the acceleration, the rate of change of the rate of change.
wait, so for the what's that point called?
Inflection?
Yeah. Do you use the second equation to solve it?
Yes.
Yes. So take the derivative of the original function 2 times, and then set that equal to 0,
No.
and you will find.
Chad scored.
Who?
Chad.
Who's Oh, Chad.
Chad.
Are we good?
Chad scored.
Yes, I'm definitely.
Yeah, we're good.
All right.
We're just cleaning our mugs.
I'm like,
I'm going to
I'm
end
like
the.
5 times smarter now.
Good.
Bye.
Bye, Bella.
Bye now.
Bye.
Dun, dun,
Da da da.